welcome to IMS GATE Academy. I welcome you all in this foundation course on theory of machine subject, right? We have started our theory of machine subject and this is the lecture number 3 in which we will be discussing about the constrained motion and the mechanism. Till now we have covered the introductory part of the theory of machine where we have discussed about what are the important parts that we have to study in theory of machine and what theory of machine is all about. And we have discussed also about the kinematic link, kinematic joint. Kinematic link, I already told you, it is a building block of kinematic mechanism, right? So that link is basically a building block of a mechanism. So that's why we need to give more stress on that link and how that links are connected with each other. That kinematic joint we need to understand. So far total this is the lecture number 3. 2 lectures are already done, and in this lecture, as I already told you, the constrained motion part and the mechanism part, and after that degree of freedom we will enter next. I hope everyone has started watching this series because this theory of machine is most important topic for your GATE preparation, not only in GATE but in other competitive examinations also, as the weightage is high and many students are facing lot of difficulty in theory of machine subject. Because of the sometimes they are not able to understand the question and they have not undergone this topic, they have not covered this topic from the basics. That's why they are facing difficulty in solving questions. So in this foundation course, I will be taking the subject from basics and then we'll definitely go to the advanced level also. In the upcoming sessions, we will be solving questions as well from different examinations, right? But as of now, we have to build our concepts so that we are in a ready position, okay? We'll be ready for the questions. And how we will be ready for questions? First, we have to cover our basic fundamentals. Okay, so let's get started in the session, guys. And before that, please join this Telegram link, right? Where you will be getting everything regarding the YouTube lecture schedules. You will be getting all the job notifications. You will be getting daily quizzes, which will definitely help you for your examinations, right? And we will also conduct some special sessions and all those information, important informations you will be getting in this Telegram channel. So link is given in the description box also, or you can directly use this link also to join this Telegram group. Clear? Next, regarding our online course offering from the IMS GATE Academy team, as you can see here, more than 800 hours of live lectures will be provided. That live lectures are, always remember, you have an option to interact with the faculty directly in the class. That is the special feature in the live classes. It is not like that only faculty is teaching and you are not able to interact. You can interact, you can ask the questions in the live class itself, okay? You can clear all your doubts in the live class itself. Apart from that, you will be getting 12 personalized mentorship sessions. This will be one-to-one personalized sessions where you can discuss all of your doubts, whatever the challenges you are facing in your GATE preparation. All your doubts will get resolved here. Apart from that, GQB book, one of the biggest important product of IMS GATE Academy, okay, premium product where you will get everything with regards to previous year questions. You will get solutions, video solution, text solutions, alternative solutions. Okay, you will be getting important key points, everything you will be getting in this particular GQB book. And also, for practice, you don't need to look for any other material. All the exercise books are divided into 3 levels, level 1, level 2 and level 3. So enough problems are given in the exercise book for your practice, right? And in the last, online test series is also provided so that you can practice, you can test whether how much you are able to perform or not. Okay, so test series is just basically a feedback mechanism, right? So please appear for the test also from the starting itself. From the starting of the preparation itself, you have to appear for test like chapter test, subject test and a multi-subject level test, right? So now we'll enter into our subject here. And in the last class, as I already told you, we've discussed about the kinematic pair, okay, or kinematic joint. I told you already. Whenever 2 links get connected, it is a joint. It is what? A joint, right? So, classification of kinematic pair based on the type of closure. In that, this is the self-closed. Okay. So, what is the self-closed? Please understand here. when the elements or the two links are connected mechanically in such a way that there is no external means is required. There is no external means is required to maintain the contact between them. This is the very important point, guys. This is very, very important point. Okay. No external means is required to maintain the contact between them. So you can take the example of this turning pair. You can take this example of sliding pair. Here the contact doesn't require any external means. They are connected mechanically, right? No external means is required so that this contact will remain as it is. That is very basic point. So such are known as self-closed. Okay. This type of pair will be called as self-closed. This type of pair is also called as lower pairs, as I already mentioned in the last class also. Lower pair means whenever there is a surface contact. Whenever there is surface contact. Clear, everyone? Okay. Now coming back to the next one, force closed. So what is force closed, guys? In force close, there is the requirement of external means so that the contact can be there. Example, cam and follower. Okay, let me show you here. So let's suppose we have, this is the cam, right? And this is the follower we have, and this follower needs what? For example, external means through spring. Through spring. Is it clear? So this is an example of force closed pair. Please remember, force closed pairs are those pairs where external means is required to maintain a contact. If that external mean is not there, then contact between these elements or these links is not possible. Is that clear? So that's why I'm telling you, in basics we have to be very, very strong. Wherever I will see two different links, I should know what type of contact it is having, what type of relative motion it is having, what type of nature of contact it is having, what type of closure it is having. Everything should be clear, then only you can understand that particular mechanism. Many people are facing difficulty in understanding how that particular mechanism will work, how the links will be moving with respect to each other, because they don't understand the link. They don't understand how the links are getting connected with each other, how the connection is there. If the connection is there, what kind of connection it is with respect to relative motion, with respect to nature of contact, with respect to the closure, right? So that's why this much basics is what required to understand any mechanism, how that particular mechanism works. That's why basics are very important. Clear? So force close is clear, self closed is also clear, right, everyone? Right? Okay. Now coming to the next part. Okay, next pair that we have is wrapping pair. Clear, everyone? See, in wrapping pair, what we have as an example is belt, pulley, chain and sprocket. For example, if I have to show you here, like how the belt and pulley will be there. So let's suppose this is the pulley 1, this is the pulley number 2, and over it there is a belt connected like this. It is rotating clockwise, it is rotating clockwise. So this is a belt pulley arrangement we have. Belt pulley arrangement. Correct? Similarly, we have a chain sprocket arrangement. So when one link is wrapped over another, that's what it is called as wrapping pair. When one link is wrapped over another link. Clear? So example, belt and pulley. So we have discussed completely about the pairs, kinematic pairs, right? This was the last topic which was left. Okay. Now coming back to the most important topic of today's lecture, constrained motion. Now what do you mean by constrained motion, and what is actually constraint? Constraint is basically the limitation, okay, or the restriction, I can say. Now what about the constrained motion? When any motion is constrained motion, it simply means it will be occurring or it will be happening in a particular or a definite way. It cannot be possible in different ways, okay. There will be definitely one definite way in which it will be having one motion. Constrained motion means only one definite motion will be there. It is not like multiple types of motions are possible. That cannot be called as constrained motion. It will be called as unconstrained motion. Constrained motion means definitely it has to be in a one particular definite way. It has to be in one particular way, okay. It cannot be in multiple ways. Simple, as simple as that. Now, types of constrained motion we have. First, completely constrained motion. Completely constrained motion, first of all. Now, what do you mean by completely constrained motion? When only one type of relative motion is possible. Only one. So that means completely constrained. Completely it is constrained. Only one type of relative motion happens, okay. That is only one type of relative motion is possible. Now I will give you example here also. So there is a rectangular block having a rectangular hole in which this rectangular bar is what inserted. Now tell me everyone, in this rectangular hole a rectangular bar is inserted. This is the cross section of the bar. So this rectangular cross section bar has been inserted in a rectangular hole only. So what kind of motion it can perform? Okay. What are the types of motion it can perform? Tell me, what will be your answer? What will be the type of motions it will perform? It will only perform a motion of sliding. Only sliding motion is possible here. It cannot rotate. Obviously it cannot rotate because this rectangular bar, a bar having a rectangular cross section, it is inserted in a rectangular hole. It cannot perform rotation. Only motion it can have is sliding. So that is the point we need to understand here. Only sliding is possible. Okay, only sliding is possible. Done. So this is known as completely constrained motion. So you need to observe this kind of motion in the mechanism, guys. Again, I am telling you, whenever you will see any kind of mechanism, you have to observe whether it is a constrained motion or not. If it is a constrained motion, what type of constrained motion it is having. Right. So completely constrained motion is one of the type of a constrained motion where only one type of relative motion is possible. One more example I will show you. Now this is a rectangular block in which circular hole is there. So circular rod or circular bar I have inserted here. Circular bar or circular rod I have inserted here. Clear? Now what kind of motion it can have? Okay, I know many people will tell कि sir sliding is also possible in this case apart from rotation. But please understand, these are the collars provided here. This is what the collar. And what is the purpose of this collar? And most important thing, first of all, this collar are integral part of the shaft. These collars are integral part of the shaft. So when this is an integral part of the shaft, what kind of motion it can have? It can have only rotation. It cannot have sliding, because when the collars are presented here, how it can slide? Sliding motion is not possible here. Okay, these are integral part of the shaft. Integral part of the shaft. Done. Now when I say integral part of the shaft, it doesn't mean that externally we are restricting the motion. We are not restricting the motion here. Please understand. Don't be confused that, sir, if the collars are not there, then the sliding will happen. Yes, definitely sliding and rotation both can happen. But when the rod is having the collar, so collar becomes the integral part of the shaft. Na? Collars are the part of a shaft which is not external to the system. Which is not external to the system, right? If it is an external part, then I would say ki there is some external means through which I have restricted the sliding motion. But in this case, collars, as I already mentioned, it is an integral part of the shaft. How you can call it as an external thing here? We can't say it is an external thing. So please understand, whenever there is a shaft in a hole, whenever there is a shaft in a hole with collars, then only rotation is possible. Only rotation is possible, right? So here also we can write only rotation is possible. Clear, everyone? Is it clear? So the first type of constrained motion we have is completely constrained. When you will call any constrained motion as completely constrained, when there is only one particular type of relative motion is possible. Only one particular type of relative motion is there. Then only we can say it is a completely constrained motion. I hope the point is clear, everyone. Now, so this is the first example where only sliding is possible. So it is a completely constrained motion. In this case, only rotation is possible. Sliding has been not, sliding basically what? Restricted. But that restriction doesn't came from the external means. That restriction doesn't come from the external means. The restriction is there because of the collars, and collars are integral part, already told you. Now next is successfully constrained motion, guys. Second is successfully constrained motion. So what do you mean by successfully constrained motion? Successfully constrained motion, tell me. What do you mean by successfully constrained motion? When more than one particular type of relative motion is possible. When more than one particular type of relative motion is possible and it is made to have only one particular type of relative motion, then it is called successfully constrained. Because actually in this particular case what happens, we have provided restriction by external means. If I don't provide that external means, then it will definitely have more than one particular type of relative motion. Please understand here. So when more than one relative motion is possible, when more than one relative motion is possible, but it is made to have only one relative motion, by using external means, by having, okay, please understand, by using what? External means. This is a very important point. So many times students are confused with this example. They consider this example as successfully constrained motion, which is totally wrong. Which is totally wrong. Because here the restrictions doesn't come from the external. Okay, restrictions are not coming from the external means, as collar are integral part of the shaft. Very important point. So what I told you here that you need to remember, more than one relative motion is possible, but it is made to have only one relative motion using external means. Example. Now see the example here. So there is a shaft here. Okay, consider this as a shaft. Actually, this is an example of footstep bearing. Right? So in footstep bearing, what happens? There is the shaft, vertical shaft we have placed here. Now this shaft can rotate and this shaft can reciprocate also. This shaft can rotate as well as reciprocate. So basically more than one relative motion is possible. More than one relative motion is possible, as already mentioned in the definition. But it is made to have only one relative motion using external means. What is that external means? This load. And this is what external to the system. That's why this example comes under the category of successfully constrained motion. Successfully constrained motion, right? Where more than one relative motion is possible, but it is made to have only one because of what? External means. Done. Now, next, third one, incompletely constrained motion. Incompletely constrained motion means what? Whenever the more than one relative motion is possible, that particular case becomes incompletely constrained motion. So please see, when more than one type of relative motion is possible. Example, a circular rod in a circular hole. A circular rod in a circular hole. In this particular case, what kind of relative motions are possible? Sliding as well as rotation. So sliding is there. Here sliding is possible. And as well as rotation. Okay. So we should write here both sliding and rotation is possible. Both sliding and rotation is possible. Right, so that's why it becomes incompletely constrained motion. It becomes what? Incompletely constrained motion. Yes or no? Correct. So total 3 types of constrained motion we are having. Again guys, please remember this thing. First, completely constrained, where only one type of relative motion is possible. Example, circular bar in a circular hole. Circular bar in a circular hole. Another example, circular bar with collar. Here actually the rectangular bar. So in this particular case, what is there? Rectangular bar in a rectangular hole. Clear? Rectangular bar in a rectangular hole, only sliding is possible. So better I will mention the name itself so that you will not confuse. Rectangular bar, okay, rectangular bar in rectangular hole. Rectangular bar in a rectangular hole. Clear? Example, in another example, circular bar with collars. In circular hole. In circular hole. Is that clear? Circular bar with collars, very important point, with collars in circular hole. Third, I've told you, second one, successfully constrained motion, right? So whenever there is a external means with which we can restrict any one motion. Basically, what is happening here? If let's suppose there is no load, what happens? This rod can rotate as well as reciprocate. Two motions are possible. But with external means, we have restricted the reciprocating motion of the rod. We have restricted, basically, we have restricted the reciprocating motion of the rod with the help of this external means, that is what load. And only now rotation is possible. So it is called as successfully constrained. So we made this motion, this particular mechanism or this particular motion as constrained motion with the help of this load, which is external to the system. That's why it is called as successfully. So difference between completely constrained and successfully constrained. Successfully constrained motions are those motions in which external means is required to make it constrained. If that external means, if I remove, let's suppose if I remove this load, then it is not a constrained motion because it will have more than one relative motion. Is it clear? It will have more than one relative motion. But for completely constant, no external mean is required to make it as a constrained motion. It is already by default a constrained motion without any need of external means. Third one, incompletely constrained motion, where there is more than one relative motion is possible. More than one type of relative motion is possible. It becomes incompletely constrained. Circular bar in a circular hole without collars. Okay, without collar is understood point, but when they are talking about collars, they have to mention collars. Otherwise, we will always take this example as without collars. If simply it is written circular bar in a circular hole, it means it is not having collars. So that's why sliding and rotation both can happen. That's why it become what? Incompletely constrained motion. Done? Okay. Now coming back to this very important topic next, that is we are having as kinematic chain. So till this point we have covered kinematic link, kinematic joint. Now coming to this point of kinematic chain. Now what do you mean by kinematic chain? Kinematic chain, I can say it is basically an assembly of different links. When different links get connected with each other, it will form a chain. There is a series of kinematic links which are connected through kinematic pairs. That series of kinematic links is actually nothing but the kinematic chain. If that chain is open, it is called as open kinematic chain. If it is closed, it is called as closed kinematic chain. Simple funda, right? So please understand, kinematic chain defined as an assembly of links and relative motion between them is constant. This is a very important point. Relative motion between them is constant. This is very, very important point. It doesn't simply means ki different links get connected, it becomes a kinematic chain. No, it will be called as kinematic chain only when the motion is constrained. When the motion between them is constrained. Very, very important point. Okay, when the motion or the relative motion between them is constrained. So that's why it is called as kinematic chain. Now there is a relation that we need to remember here. Okay, that relation is J plus H by 2 equals to 3 by 2 L minus 2. This is the relation. Now in this relation, what you need to remember, if LHS equals to RHS, it is called as constrained. It will have constrained chain, constrained motion. If LHS is greater than RHS, considered as a logged chain, and if LHS is less than RHS, unconstrained. Unconstrained. Please remember this particular relation, very, very important. Now the question here will be, sir, what is J, what is H, what is L? So J, here you should write J is binary joint. H higher pair. And L is link. Okay, L is number of link basically. Right? Using this relation, you can tell whether the chain is constrained kinematic chain, or it is logged chain, or it is unconstrained chain, using this relation. Clear, everyone? So kinematic chain is nothing but the assembly of links, and the relative motion between the links has to be what? constrained, then only it is considered as a kinematic chain. Otherwise, we can't say it is a constrained kinematic chain. Is it clear, everyone? Very basic thing. So let us see some example also, okay, and we will apply this relation, okay. Next, let's suppose any one example if I take. Okay, tell me whether it is constrained, unconstrained or logged. Okay, it is considered as constrained, unconstrained or logged. You need to first find out number of links, you need to find out number of binary joints and number of higher pair. Right, so first of all you need to find out this data and put it in this particular relation and find out whether LHS and RHS are equal. If it is LHS is more or RHS is more, figure out and then tell me whether it is constrained, logged or unconstrained. Do it everyone fast and tell me your answer. And here the information or the knowledge of joints is what required, okay. And I hope you remember what is binary joint. A joint which has been formed when two different links get connected. Ternary joint when 3 links get connected. Quaternary joint when 4 links get connected. So that information is required here, okay. That we have already discussed in the yesterday's session, last session basically. Do it everyone fast. Constrained or unconstrained or logged. First of all, number of links, okay. Let me mention number of link first. One, this is 2, 3, 4, 5 and this is 6, correct. Total 6 links we are having, fine. Now what about the binary joints? This is called as one binary joint. How I figure out it is a binary joint? Because 6 and 1 are connected here. Here 1 and 2 are connected, so one binary joint. Here 3 and 5 are connected, so one binary joint. But here 5, 4 and 6, 3 are connected, so ternary joint. And you know that ternary joint, one ternary joint is equivalent to 2 binary joint. This we have already discussed in the last session. One ternary joint is equivalent to 2 binary joint. Similarly, this joint 3, 4 and 2 are connected, so one ternary joint it is, which is equal to 2 binary joint. So in total, first of all, number of links are 6, right? Number of binary joint, see 1, 2, 3, 3 and 4, 7. What about the higher pair? 0. Higher pair, how you will figure out? Whenever there is a point contact or a line contact, then we will say it is a higher pair, right? Okay, fine. Now this values I will be using in this relation, this one. So relation, what was the relation? Let me write it here. J plus H by 2, 3 by 2 L minus 2. J, what is the value of J? 7, right? It is 0, 3 by 2 into L, that is 6 minus 2. Is it clear? So this is what 7 it is. 3, 6 divided by 2 becomes 3. 3 and 3, 9, 9 minus 2, 7. So on both the sides, 7 we are getting. On both the sides, we are getting S7. So here LHS equals to RHS. So when LHS equals to RHS, it is considered as constrained kinematic chain. It is considered as constrained. Right? So let me give you one more example. Is it clear, everyone? One more example. So let us do some little modification in the previous problem only. Okay, now in this particular case, how you will solve? First of all, number of links, binary joints, number of higher pairs. Do it fast, everyone. Small change I have done here. Now again, if you don't have a basic understanding of link, you will not be able to solve this one. I've told you what are the different types of link: rigid link, flexible link, and a fluid link. These are the basic three classification. After that, I have discussed binary link, ternary link, and quaternary link. This classification is based on the number of ends of any particular link. If any particular link is having 2 ends, it is called as binary link. If any link is having 3 ends, it is called as ternary link. And if any link is having 4 ends, it is considered as quaternary link. I hope this is clear, everyone. Now in this case, first of all, number of links: link number 1, link number 2, link number 3, and this is link number 4. And I've told you, whenever there is a link having more than 2 ends, like ternary or quaternary, like this. If this is a ternary link, we need to mention these linings. If this is a quaternary link, we need to mention these lines. Okay, whenever these lines are drawn, it means it is considered as a single link. It is considered as a single link. Don't count this one as 3 link and this one as 4 link. Never do this kind of mistake again, right? Okay. So number of links we have as 4. Number of link is 4 here. Now coming back to this binary joint, one binary joint. Again, at this point, how many links are connected? Link number 4 and link number 3. So one binary joint. Again here, link number 2, link number 4. One binary joint. What about this one? No joint. Okay. This is a completely ternary link it is, right? So one binary, total 4 binary joints we have. And number of higher pairs 0. Now using this relation, J plus H by 2, 3 by 2 L minus 2. So J, binary joints are 4, number of higher pairs 0, 3 by 2 L, L is number of links minus 2. Okay, 3 into 4 divided by 2, 6. 3 into 4, 12 divided by 2, 6, 6 minus 2, 4. So again in this case, LHS and RHS are equal. So we can say it is constrained chain. Is it clear? It is a constrained chain. Clear, everyone? So chain, kinematic chain is nothing but the assembly of different links which are connected through kinematic joints. or kinematic pairs. But most important part is that chain will be called as kinematic chain when the relative motion between the different links is constrained. This is a very, very important information, guys. Okay, fine. Kinematic chain is done. Now coming to next part, very important, that is mechanism. So this chapter name is itself called as mechanism. Till now, what definition of a mechanism we are having? Mechanism is the device which is used to transform the input motion into output motion. And what is output motion? That is what we have desired. Desirable pattern of motion. A device which transforms the input motion into desirable pattern of motion, that particular type of device is known as mechanism. And when we are discussing about mechanism, we will never talk about the force, power or work, because we are concerned about the motion. Main predominant idea is of achieving the desired pattern of motion. I am not concerned about the forces involved or the forces associated with those motions. I am only concerned about the input motion that I have given and what is the output motion I am getting, and how that transformation of motion happens within the mechanism. I am only concerned about the motions, not the forces which are associated with the motions. Clear? So in mechanism, now coming back to the actual definition of mechanism. If in a kinematic chain, if any one of the link gets fixed, fixed links is also called as frame of reference. That fixed link will behave or serve as a frame of reference for other links. Then that kinematic chain is called as a mechanism. But mechanism, it will be there when it is having a constrained motion. Again, very important part. Simply, as I told you, if I connect different links, it becomes a chain. That chain becomes kinematic when it is a constrained motion, when there is a constrained motion between the links. Similarly, in the chain, if any one link fixed, it doesn't mean that it becomes mechanism. It will become mechanism when there is a constrained motion. If only one link is fixed in the chain, it will be called as linkage. It will be called as linkage. It will convert to mechanism when there is a constrained motion. When there is what? A constrained motion. Very, very important point, guys. If someone says in a chain, if I fix one link, it becomes mechanism. Yes, but there is one more condition. What is that? There should be a constrained motion. Then only it is called as mechanism. Otherwise, it will be called as simply linkage. Like chain called as a kinematic chain when there is a constrained motion. So why we will actually fix? Because the fixed link will behave as a frame of reference. It will serve as a frame of reference for other particular links. This point you should remember, right? So that's what we have written. When one element or link of a kinematic chain is fixed, the arrangement may be used for transmitting or transforming motion. It is then termed as basically a mechanism. Now, please go back into the basics part. First, we have discussed about kinematic link. Okay. We talk about kinematic link, right? In kinematic link, we talk about rigid link, flexible link, and fluid link. Another classification based on number of ends of a link: binary link, ternary link, quaternary link. Fine, done. So the link understanding is clear. Coming back to the connection between the link, how the links are connected with each other, how that particular connection is. So based on different criteria, we have classified the kinematic connection, or that is kinematic joint or kinematic pair. So next thing is what? Kinematic joint. And kinematic joint classification also we have done based on number of links get connected, based on nature of contact, based on type of relative motion, based on type of closure. I hope this is clear, everyone. How many links get connected? First, basis of classification. Second, type of or the nature of contact between the links, surface contact, point contact, line contact. Third, based on type of relative motion, turning, rotation, sliding, okay, cylindrical pair, spherical pair, screw pair, different pairs we have discussed. And then based on type of closure, self-closed, forced closed, like that. Now, after kinematic link, kinematic joint, we have talked about kinematic chain. We have talked about kinematic chain. And then we have talked about what? Mechanism. When any one of the link in the kinematic chain is fixed, it becomes mechanism. Okay. But please understand, if any one link fixed in the kinematic chain, it will be called as linkage, but that linkage will become mechanism when there is a constrained motion. There should be a constrained motion in the mechanism. Okay. Once just fixing one link doesn't mean that it become a mechanism. That is very important detail, guys. Just fixing any one particular link doesn't make sure that, doesn't guarantee that it become a mechanism. It will become mechanism when there is a constrained motion. Please remember this point, very important. So just by fixing one link doesn't mean that it will become a mechanism. Condition is it has to be what have? It has to have what? The constrained motion. So this idea you should be having in your mind. Kinematic link, clear understanding you should be having. Kinematic joint understanding you should be having. Then chain, and then coming back to mechanism finally. Right. So in the next lecture, I will be discussing about the degree of freedom. Okay, because in the mechanism, degree of freedom is one of the most important parameter. Okay, which is also known as mobility. So that parameter we will be discussing in the next session, right? But till this point, I hope every small basic detail is clear to everyone. Introduction part of theory of mechanism, okay, theory of machine basically. And then we have talked about kinematic link, kinematic joint, kinematic chain, mechanism we have discussed. We have discussed different types of constrained motions. All those basic things we have discussed. In the next session, we are going to discuss about the degree of freedom, most important topic for the GATE examination. Okay. Now, from the next upcoming sessions, we will be discussing some questions as well. Now, all the basic theoretical part we have covered. After that, we are going to discuss some questions as well from different examinations. So, if you are really enjoying this particular session, guys, please share this session to your friends which are currently studying in the college, because this foundation series is basically focusing on the basic part of the subject. Okay, it is not like if we are directly entering into the numericals. This session is basically for those students who have never studied theory of machine till now. They are maybe in the college, or they may be passed out from the college, and they don't have that much basics clear in the theory of machine subject. So these lectures are suitable for those students who really want to make sure that the basic part or the fundamental part of a theory of machine will become strong for them. So I will make sure, I will guarantee you, if you attend this foundation series of theory of machine, you will never face any difficulty in theory of machine, because right away from the basics we are going into the subject. We are going into details from the basic points. Clear? So I hope you are enjoying the session. So please share this session, and tomorrow's session, degree of freedom, we are going to start. So please don't miss next lecture, which will be based on degree of freedom of mechanism. Thank you so much, guys. We'll meet you tomorrow's session. Thank you. Bye-bye.